My dear students, today we'll continue our lectures for the third course students for the Pharmaceutical Chemistry 2, and our topic, you can see on this slide the full title of our topic: Aromatic compounds, the derivatives of para-aminosalicylic acid, the derivatives of ortho-aminobenzoic acid or antranilic acid, aryl alkylamines, phenyl alkylamines, the derivatives of aryl oxypropanol amines or beta-adrenal blockators, nitrophenyl alkylamines, oxyphenyl aliphatic amino acids, the iodine derivatives of aromatic and aryl aliphatic amino acids. If you remember at our last lecture, I said that that during two lectures we'll speak about aromatic compound. Therefore, today the second lecture there will speak about aromatic compounds. If the first lecture. At our first lecture, we spoke about the simple aromatic compounds, for example, phenols, the quinones substances, and we take some preparation which has a K vitamins activity, and we speak about alicyclic antibiotics, for example, tetracyclines, which have the first cycle, aromatic cycle, and they are derivatives of tetrazine, naphthazine. Today we speak about other aromatic compounds, for example, the derivatives of para-aminosalicylic acid. Please look at the first slide, and you can see sodium para-aminosalicylate, and you can see this structure, natrium para-aminosalicylase or natrium PAS. Sodium para-aminosalicylate are the name of this preparation, and you can see that this preparation has in para position amino group, has phenol hydroxyl in the structure, and has natrium atoms in this structure. Therefore, the chemical name of this preparation, natrium salt of para-aminosalicylic acid. When we speak about preparation, this substance obtained from meta-aminophenol. During carboxylation of meta-aminophenol and in the present sodium hydrocarbonate, in the temperature medium and in the pressure, we receive para-aminosalicylate sodium or PAS sodium. And when we speak about identification, first of all you must look at the structure of this preparation, and we can see that in the structure primary aromatic amines, in the structure phenol hydroxyl, and sodium in the structure. Therefore, this preparation gives reaction for sodium, dye the flame in yellow color. For primary aromatic amines gives the reaction, and phenol hydroxyls. Please look at these reactions. Identification with 2,4-dinitro-chlorbenzene preparation give reaction forming yellow colored product, yellow color product with dinitrochlorobenzene. Then when we check of purity we determine impurities. And you know that the primary substance a lot of time may be impurities in this preparation, and impurities of this preparation may be maybe meta-aminophenol, and for determination meta-aminophenol we use different substance which has primary aromatic amines. For example, para-nitroaniline, when we reacts with sodium nitrate in hydrochloric acid, we receive diazonium salt, and diazonium salt, when in our preparation there is impurities meta-aminophenol, meta-aminophenol reacts with diazonium salt and form other dye which has orange-red color. When form orange-red color, it means that in our preparation there is impurities meta-aminophenol. Before speaking about assay, quantitative determination, I want to say that this preparation gives reaction with ferric chloride, and you know that reaction with ferric chloride is specific reaction for phenols, and because this preparation have phenol hydroxyl, with ferric chloride gives violet color, red-violet color, and because of this preparation has primary aromatic amines, and you know that primary aromatic amines gives other dye, and in this reaction, this preparation takes part as other component, and as the other component we can take, for example, para-nitranilin and different or other substance which have primary aromatic amines. And at the end of reaction, we're forming other dye which have orange-red color. Now we speak about assay. Because of this preparation has primary aromatic amines, this preparation is determined by nitritometric method, and nitritometric method belong to chemical volumetric method, and nitritometry method in nitritometry method we use as titrant sodium nitrate. And as indicator can use three kinds of or three types of indicators. The first indicator, inside indicator, for example, tropyalin 00 or mixture tropyalin 00 with methyl red, or mixture methyl red with methylene blue. May be used as inside indicator. The second one outside indicator, for example, starch. Starch, iod, paper, or potentiometrically the third way to determination to carry out of nitritometric method. And second method of quantitative determination of this preparation, natrium pass, iod chlorometric method, and you can see this method on this slide, and at the end of reaction form iod derivatives of this preparation, and iod chloride with potassium iodide give iodine, and our iodine, the surplus or the excess of iodine, we determine with thiosulfate sodium in the present starch. When we add to iodine solution starch, we form blue color, and when we titrate it with thiosulfate sodium, blue color change in colors. The third method of quantitative determination is neutralization method, or acidometric method, because of this preparation has sodium, we use acidometric method. First of all, we add formaldehyde, and we primary aromatic amine change in this radical, then hydrolyzes these substances. We receive acid of this preparation, and in the presence indicator thymol blue. The first method, spectrophotometric method, and in the base of this method lie the colored reaction. For example, reaction forming other dye, reaction for 2,4-dinitrochlorobenzol, and other colored reaction which we use for identification of this preparation. And you must know that sodium para-aminosalicylate or para-aminosalicylate is anti-metabolite of para-aminobenzoic acid, PABA. And para-aminobenzoic acid, you know that being necessary to the growth, for the growth of microorganism. Therefore, para-aminosalicylate or the derivatives of para-aminosalicylate are the anti-metabolites of para-aminobenzoic acid. The second preparation, bipascum or calcium benzamidosalicylate. You can see in the structure of this preparation, there is calcium, there is benzoyl radical. Therefore, this preparation name calcium benzamidosalicylate or bipascum. For preparation of this preparation, we use para-aminosalicyllic acid, PASA, para-aminosalicyllic acid, and chloranhydride of benzoic acid, and then we add sodium hydrocarbonate. We receive this compound, we receive benzamidosalicylate, and when we react with calcium chloride, we receive bipascum. This preparation, bipascum. And when we speak about identification, we must say that preparation, when we add hydrochloric acid, form calcium chloride, and calcium chloride, you know, gives reaction with oxalate ammonium. At the end of reaction, we receive white precipitate. And if you will look at the structure of bipascum, you can see phenol hydroxyl in the structure. Therefore, this preparation also give reaction with ferric chloride as natrium PAS, and at the end of reaction form violet color, and this reaction specific reaction for phenols. And when we speak about assay of this preparation, BPASC, we must say that this preparation is determined by a complexometric method. And you know this method from the first semester, and you know that complexometric method is a quantitative determination of all of the preparation which have calcium, magnesium, bismuth, and other metals. And in complexometric method, we use as titrant sodium editate or trilon B, and as in this case, as indicator, we use eriachrome blue, or also we use murixide. We also use murixide. It's a complexometric method for determination. And you must know that sodium PAS, para-aminosalicylate sodium, and bipascum, calcium benzamidosalicylate, which are anti-metabolites of para-aminobenzoic acid, are used in medicine as anti-tuberculosis preparation during treatment tuberculosis. And after this preparation, we take the derivatives of antranilic, phenylacetic and phenylpropionic acid. Before we taking this information, I want to remind you about anti-inflammatory remedies. If you remember, at our last lecture, when we speak about at our second lecture, when we speak about steroidal anti-inflammatory remedies, and when we speak about about corticosteroids, the hormones of cortex part of the adrenal gland, I said that this preparation, corticosteroid, namely glucocorticosteroids, are steroidal anti-inflammatory remedies. But today we take non-steroidal anti-inflammatory remedies and some groups of non-steroidal anti-inflammatory remedies. For example, the derivatives of antranilic, phenylacetic, phenylpropionic acid. And you must know that non-steroidal anti-inflammatory remedies are also divided into two groups. The first group, the non-selective inhibitors, cyclooxygenase 1 and cyclooxygenase 2, and second one, selective inhibitors, cyclooxygenase 2. And this preparation belongs to the first group. It's mefenamic acid, acidum mefenamicum, orthophenum, its other name Voltaren, or diclofenac sodium. Please look at the structure of mefenamic acid. You can see that mefenamic, in the base of this preparation, there is antranilic acid, and antranilic acid is meta-aminobenzoic acid. Therefore, the name of this chemical name of mefenamic acid, N, 2,3-dimethyl phenyl antranilic acid. Dimethyl phenyl antranilic acid. Orthophen or Voltaren diclofenac sodium also belong to non-steroidal anti-inflammatory remedies, but it is not derivative of antranilic acid. It's derivatives of phenylacetic acid, because in the base of this structure lie phenylacetic acid, and the chemical name of this preparation, natrium salt of 2,6-dichlorphenylamino phenylacetic acid. To non-steroidal anti-inflammatory remedies also belong the derivatives of phenylpropionic acid. You can see phenylpropionic acid here, and its preparation ketonal or ketoprofen, fastum gel also name, and you can see this structure 2,3-benzyl, you can see phenylpropionic acid. This preparation also belongs to non-steroidal anti-inflammatory remedies. Now we speak about identification when it's acid, for example, mefenamic acid, during hydrolysis gives natrium salt of mefenamic acid, and when we hydrolyzes hydrochloric acid, first one hydrolyzes with natrium hydroxide, but the second one hydrolyzes with hydrochloric acid, form acid as precipitate. When we speak about diclofenac sodium, when hydrolyzes forming acid, which has white precipitate, and with precipitate change in indolinone. And you can see the structure at the base, indolinone structure preparation. When we speak about next preparation, ibuprofen, brufen, also derivatives of phenylpropionic acid, and belong to non-steroidal anti-inflammatory remedies. Now we take the following part of our lecture. We speak about phenylalkylamines, aryl alkylamines. Before taking this part, I want say, because of our subject, pharmaceutical chemistry subject, the chemical classification is interesting for us. Therefore, all of the preparation which are used in medicine and which belong to phenylalkylamines divided into three groups. The first group, phenylalkylamines itself, for example, ephedrine. preparation, ephedrine. The second group, or oxyphenylalkylamines, which have one oxy groups. If phenylalkylamines have only alkylamine in the structure and have no other radical in the structure, oxyphenylalkylamines have one hydroxyl group in the structure. For example, some preparation mesotone, phenol. And the third group, deoxyphenylalkylamines. Deoxyphenylalkylamines are divided into two groups, orthodeoxyphenylalkylamines and metadeoxyphenylalkylamines. To orthodeoxyphenylalkylamines, and we will speak later, belong catecholamines. But to metadeoxyphenylalkylamines belong other preparations, for example, salbutamol, or sprenaline sulfate, or alupent asmapent, or phenaterol or beratec, which are used in treatment, for example, bronchial asthma. This preparation has properties which narrow down the blood vessels, or constrict the blood vessel and expand the bronchi. And the first preparation, which belongs to phenylalkylamines, it's ephedrine hydrochloride. Ephedrine hydrochloride is ephedrine is alkaloid, and alkaloid which we obtained from plant Ephedra monosperma. And this alkaloid belongs to non-heterocyclic structure alkaloid, non-heterocyclic, because in the base of the structure phenol group, and the name of ephedrine belong to aromatic group preparation. Name of ephedrine L-erythra 2-methylamina 1-phenylpropanol 1-hydrochloride. It means that pharmacological active substance is L-erythra isomer. But in medicine also use, except ephedrine hydrochloride, diephedrine, it's pseudoephedrine hydrochloride. And pseudoephedrine hydrochloride is the-trio isomer, and ephedrine hydrochloride has two asymmetric carbon atoms, therefore has 4 isomers. And ephedrine, pseudoephedrine, has L and D forms. You can see L-ephedrine, D-ephedrine, and you can see L-pseudoephedrine and D-pseudoephedrine. If we speak about preparation, there are several methods of preparation. The first method, biosynthesis method. Biosynthesis method, from benzaldehyde, we receive 1-phenylacetyl carbinol. Then hydration of this preparation form ephedrine, and when we react with hydrochloric acid, we receive preparation ephedrine hydrochloride. It's the first method, by synthesis method. The second method, synthesis method, and synthesis from benzene and chloroanhydride of chlorpropionic acid in the present methylamine, and then hydration. We receive L-ephedrine or erythroisomer and the pseudoephedrine trioisomer. The advantages of these methods that we receive L-ephedrine and the L-ephedrine trioisomer and the pseudoephedrine erythroisomer. When we speak about identification, you can see that ephedrine with red blood salt, hexacyanoferrate kalium, we receive benzaldehyde and methylethylamine. Benzaldehyde has specific smell with And in the first case, in the second case, benzaldehyde and acetic aldehyde and methylamine. Benzaldehyde has almond smell, and you can see that at the end of reaction, form methylamine and methylethylamine. These substance we can determine as ammonia. You know that ammonia we determine by smell, with Nestle reagent, with failing reagent, and etc. And the second reaction for ephedrine, forming complex with copper sulfate, and this copper has blue color. You will say about assay, I can say that the first method of assay, non-aqueous titration, and you can see this reaction, non-aqueous titration, and non-aqueous titration may carry out into ways. The first way, without hydrogen acetate, in this reaction, preparation with acetic anhydride and perchloric acid in the presence formic acid goes this reaction. As citrant we use perchloric acid, and in the presence violet crystal and is indicator in the first way. The second way, in the presence of hydrogen acetate. Also we use as citrant perchloric acid and use crystal violet. The second method of assay, argentometric method or Fiennes method. You know that argentometric method divided into three kinds: Figent method, Folgert method, and Moore method. But in this case, we use Figent method. And the third method, neutralization of alkalimetric method, because this preparation used as hydrochloride, therefore we determine by alkalimetric method and indicator phenolphthalein. The second preparation which determine two phenylalkylamines, but if we say exactly to determine orthodeoxyphenylalkylamines, dopamine or dopamine, and you can see the structure. It's the chemical name 2,3,4-deoxyphenylethylamine hydrochloride, and used in medicine as hydrochloride. And dopamine is dopamine ergic preparation used in different heart diseases. And dopamine in organism by synthesis in medulla part of adrenal gland, and from phenylalanine amino acid, tyrosine, phenylalanine oxidize and change in tyrosine. Tyrosine oxidize change dopa or levodopa, dofa, and during decarboxylation forming dopamine, and then forming noradrenaline and forming adrenaline. Noradrenaline, other name norepinephrine, adrenaline epinephrine. And I want to say that dopa, levodopa, used in medicine as anti-Parkinsonic preparation. If you remember, we took earlier anti-Parkinsonic preparation, for example, the derivatives of adamantan and midantan, memantine, gludantan. Levodopa also is used in medicine as anti-Parkinsonic preparation, and in medicine also use combined preparation of levodopa, for example, Nacom, Madapar, and levodopa has in combination in NACOM, the inhibitor of peripheric decarboxylation of levodopa, carbidopa, and in Madapar has also inhibitor of peripheric decarboxylation of levodopa, benzyrazide. If carbidopa belong to orthodeoxyphenylalkylamines, benzyrazide belong to derivatives of pyrogalol. We said about dopamine, and noradrenaline, adrenaline belong to adrenomimetic, sympathimimetic preparations. These preparations constrict or narrow down the blood vessels and expand the bronchi. When we speak about dopamine and when we speak about preparation of dopamine, you can see that dopamine synthesis from homoviretylamine, and you can see the structure, and in difference from dopamine has two oxymethyl group in the structure, and during when we take off methyl radicals in the structure and lose the two methyl radical in the structure, form dopamine. When we speak about identification, I can say that these preparations, all of this preparation, dopamine, this preparation has you can see has phenyl hydroxyls in the structures, and this phenyl hydroxyl, you know that all of the phenols gives a specific reaction with iron chlor free. Therefore, this preparation gives levodopa, dopamine, noradrenaline, adrenaline gives reaction with ferric chloride and form green color, and after the first reaction for ferric chloride, there is other reaction identification when this preparation take part as other component, and we take as the other component different preparation which have primary aromatic amines at the end of reaction forming other dye, and other dye with zirconium chlor oxide form complex which have red-violet color, and lambda maximum of this complex 515-525 nanometer in the second reaction for these preparations. And if we say about the third reaction forming, for example, other dye. And now we speak epinephrine hydrochloride or adrenaline hydrochloride. Adrenaline can use in medicine as hydrochloride and hydrotartrate or bitartrate. Hydrotartrate or bitartrate, and the chemical name of adrenaline L1 3,4-deoxyphenyl. You can see in 3,4 position deoxyphenyl, 2-methyl, aminoethanol hydrotartrate, aminoethanol hydro. In this position, 2-methyl aminoethanol hydrotartrate hydrochloride. When we speak about preparation, synthesis of adrenaline, noradrenaline from catechol, and when we use chlor anhydride, monochlor acetic acid, we use this chlormethyl 3,4-deoxyphenyl ketone, and with methylamine gives adrenaline. First of all, adrenaline which have keta group in this position, and when hydration we receive adrenaline. And except adrenaline in medicine practice is used adrenaline dipivalate or dipivefrin, and you can see this structure, and adrenaline dipivalate is used has the same using, and used as adrenomimetic, sympathimimetic preparation, which constrict or narrow down the blood vessels and expand the bronchi. When we speak about identification, also use reaction, colored reaction with ferric chloride and form the complex with iron which have green color. And adrenaline, noradrenaline also in organism oxidize, and adrenaline lose methylamine, but noradrenaline or norepinephrine lose ammonia, and at the end of reaction form deoxyaldehyde. When we speak about identification, adrenaline, noradrenaline, this substance gives a reaction with iodine, with buffer solution of iodine in the presence of sulfate sodium, and for adrenaline use pH 3.56 and 6.5. For noradrenaline use the pH 6.5. At the end of reaction form adrenochrome, noradrenochrome, and oxoadrenochrome, oxonoradrenochrome, and this has violet and violet red color. When we speak about assay, you must say that this preparation use non-aqueous titration. Non-aqueous titration, you know this method, this volumetric chemical method, and non-aqueous titration we use in non-aqueous titration we use acetate perchloric acid, as indicated violet crystal. And the second method, photometry method, because this preparation gives colored reaction, and also use spectrophotometric method for quantitative determination of this preparation, namely adrenaline or epinephrine hydrotartrate. You can see the structure of norepinephrine hydrotartrate or betatartrate or tartrate, you can see, and also norepinephrine has 2 hydroxyl groups in position 3-4, and norepinephrine as epinephrine as levodopa dopamine belong to catecholamines, and you must know adrenaline, noradrenaline, and other related amines which have 2 hydroxyl groups in position 3-4 are called catecholamines. You can see also chemical name or norepinephrine L1,3,4-deoxyphenyl 2-aminoethanol hydrotartrate. When we speak about preparation, you must say that this preparation received from catechol as epinephrine with amino acetal, reacts with amino acetal, form norepinephrine, the L isomer of norepinephrine. You must know that L isomer more activity than the isomer, and its activity in 15 times more activity than the isomers for epinephrine. When we speak about isoprenaline, isoprenaline hydrochloride, you can see that isoprenaline has this structure, and chemical name isopropyl noradrenaline hydrochloride, isopropyl noradrenaline hydrochloride. Isodrine also obtained from catechol, is obtained from catechol, and in present with reacts chloranhydride or monochloroacetic of monochloroacetic acid, and you can see this reaction, and you can see in the present isopropylamine we receive this substance, and hydration receive isodrine base, and with hydrochloric acid we receive isodrinum or isoprenaline hydrochloride. Ephedrine also gives reaction as epinephrine and norepinephrine with iodine buffer solution iodine in present thiosulfate sodium and forming ephedrine chrome or ephedrine chrome or oxaephedrinochrome, and in this reaction carries out is carried out as adrenaline epinephrine in pH 3.4 and pH 6.5. When we speak now, we'll look at the structure of midodrine. And midodrine, or other name gutron, is used as epinephrine, norepinephrine, adrenomimetic, sympathimimetic. Therefore, we take this preparation in this section, and this preparation constrict or narrow down the blood vessels and expand the bronchi. When speak about hydrolysis of midodrine, we can see that during hydrolysis form this glimidodrine and glycine. I want to say that all of the adrenomimetic, sympathimimetic preparations has hypertensive activity and use during hypotensia. Now we take the second part of our lecture, and we speak about derivatives of aryl oxypropanol amines or beta adrenoblockators, and we speak about nitrophenylalkylamines, oxyphenyl aliphatic amino acids, and iodine derivatives of aromatic and aryl aliphatic amino acids. Please look at this slide, and you can see that aryl oxypropanolamines or beta adrenoblockators are antagonists of adrenomimetic, sympathimimetic preparations. And you can see the first representative of this preparation, anaprylene, other name indicardine, obsidan, propranolol hydrochloride. Anaprylene, Latin name, propranolol hydrochloride is INN name of this preparation, and there is other trade name, indicardine, and obsidan. The next preparation, visgen or pindalol, you can see in the base of this preparation lie indole, benzpyrrole structure, and this preparation also adrenoblockator, cardanum or talinolol, also adrenoblockator, and trazicor, and you can see this structure. Trazicor used as hydrochloride. Some of this preparation used as hydrochloride, and at the start of hydrochloride acid, this preparation gives reaction for chloride. Also, this preparation for assay of this preparation use non-aqueous titration, and this preparation during non-aqueous titration used for this preparation as citrand perchloric acid as indicated violet crystal, and also this preparation used during different disease, vessel disease, heart disease, and etc. And this preparation, because of antagonist of adrenomimetic preparation, has hypertensive activity, hypotensive activity, and using during hypertonia. And when we speak about nitrophenylalkylamines, we must say that to nitrophenylalkylamines belong antibiotics. For example, levomycin or chloramphenicol, levomycin, Latin name of chloramphenicol, INN name of this preparation, INN, it means international non-proprietary name. And if you remember, we took antibiotics, for example, tetracycline, at our last lecture, and in our last semester, we took also other antibiotics, beta-lactam antibiotics. For example, penicillins and cephalosporins. But now we take penicillins, cephalosporin belong to heterocyclic structure antibiotics. Tetracyclines belongs to alicyclic structure, but tetracycline has the first cycle is aromatic, and therefore we took at our last lecture. But today we took also aromatic structure antibiotics, for example, the derivatives of nitrophenylalkylamines, levomycin. And you know that antibiotics, that substances which are produced by other microorganisms and to inhibit or to destroy other microorganisms. And you can see levomycin. Levomycin is produced by Streptomyces venezuela, and levomycin, you can see, has this structure, and in para position has nitro group, and levomycin has two asymmetric carbon acid, and the active form of levomycin, which is used in medicine as drug, as medicine, the trio 1 para nitrophenyl 2 dichloracetylamine propandiol 1 free. And if the preparation has two asymmetric carbon atoms, therefore has 4 isomers, and you can see trioisomers, erythroisomers, but the active form of levomycin, the trioisomer. And when we speak about preparation, synthesis of levomycin, we synthesis from para-nitroacetophenone. When bromination of this substance, we receive para-nitro-alpha bromacetophenone. Then we reacts with hexamethylene tetramine or hexamethyl hexamethylene tetramine, and form para-nitro-alpha amine acetophenone hydrochloride, and reacts with acetic anhydride, we receive para-nitro-alpha acetylamine acetophenone. And you can see that with formaldehyde, we receive this substance, and then reductation, then hydrolyzes, and hydrolyzes with sodium hydroxide, we receive levomycin or levomycin base. Levomycin base, only levomycin base, and when we react with methyl ether of dichloracetic acid, we receive methanol and levomycin. And you must know that levomycin here as D-trio and L-trio mixture, D-trio and L-trio mixture, and to this mixture we add tartaric acid, and you must know that D-trio levomycin, this D-trio levomycin, which is activity, has physiology activity, dissolved in methanol, and because these physiological properties, we can separate the trioisomers from L-trioisomers. you must know that mixture D-trio-L isomers are used in medicine as preparations and used as ointment, streptomycin, and it's called streptomycin. When we speak about identification, because of levomycin, mycin has nitro group in the structure, we reduction and use zinc powder and in hydrochloric acid, we receive amino derivatives of levomycin, and these substance we show as radical, and we show this reaction. If the preparation which have first primary aromatic amines with sodium nitrate in the presence of hydrochloric acid form diazo salt, and diazo salt with different other component, for example beta naphthol, N-phenyl alpha naphthylamine, and 1-naphthyl ethylene diamine hydrochloride gives a different azodie. The first case, in the first case, azodie orange ray. In the second case, azodie blue-violet color. In the third case, azodie violet color. And except levomycin, we use levomycin stearas, and you can see this structure when methyl radical, 16 methyl radical, and levomycin palmitate, in palmitate methyl radical 14 methyl radical, and levomycin succinase soluble or chloracid C. Levomycin succinase soluble in water. Its advantages when we compare with other levomycin. And levomycin is used in medicine as antibiotics and against gram-plus, gram-minus antibiotics, and has antiseptic remedies, antiseptic properties. The other preparation, seminal also used as levomycin, and also has belong to nitrophenyl group, has nitrophenyl alkyl groups, but has in the structure aldehyde groups. Therefore, if has aldehyde groups, gives reaction with failing reagents, gives reaction with gives silver mirror reaction, and all of the reaction which gives aldehyde groups. The second part, the following part, not say, seminal also has, I said before, also has antiseptic properties and use an antiseptic, antimicrobe preparations. The following part of our lecture, the iodine aliphatic amino acids. You can see the different substances which have iodine, and for example 3-monoiodotyrosine, 3,5-diiodotyrosine, and 3,5-3-iodotyrosine, 3,5-3-iodotyrosine, and 3,5-3-5-tetraiodotyrosine or thyroxine. In the base of this preparation lie amino acid tyrosine. And you must know that thyroid gland secretes hormones which regulate the metabolic rate in our organism. And the main part of this hormone, L-thyroxine. L-thyroxine is a tetraiod derivatives of derivatives of amino acid tyrosine. And in medicine practice, use thyroidine as preparation, and thyroidine consists of two substances. First of all, L-thyroxine, which is 3,5-5-tetraiodthyronine, and leotyronine. Leotyronine is 3, 5, and 3-triiodthyronine. And except thyroidine, also used in medicine practice, L-thyroxine, which also tetraiodthyronine, and used as synthetic preparation, leotyronine, which is 3-5-triiodthyronine. If the natural preparation thyroidine include 3,5-3-triiodthyronine, in synthetic preparation leotyronine include 3-5-triiodthyronine. The difference between each other. These preparations, thyroidine, leotyronine, L-thyroxine, or levothyroxine, are used as thyroid hormones, and during different disease for example, tumor of thyroid gland, or during hyperfunction of thyroid gland, But during hyperfunction or thyroid gland, I use anti-thyroid preparations, and first representative of anti-thyroid preparations, mircazalil or metimazole, timadazole or thiamazolum, and mircazalil, and then Latin name of this preparation, but metimazole or INN name of this preparation, and you can see in the base of this preparation lie imidazole, the structure of imidazole, and the chemical name of this preparation 1-methyl-2 mercapta imidazole. It's anti-thyroid preparations. You can see also on this slide the identification reaction of this substance. Preparation with silver nitrate form white precipitate of silver salt of mercazalil, which dissolve in water and dissolve in nitric acid. The next preparation the next part of our lecture, X-ray contrast agents or diagnostic substances. There are different diagnostic substances, for example, bilignost or adipiodanum. This preparation used as X-ray contrast agents for analyzers for using gallbladder or biliary tract in organism. Idomit used for analyzers as X-ray contrast agents for diagnostic blood vessels. The third preparation, iopagnost or acidum iopanoicum, and which has free iodine in the structure. This preparation also used for analyzes gallbladder or and biliary tract in the body. And thrombrast, and used in medicine 60% out, 76% pro injectionibus of this preparation. Thrombrast is used for analysis as X-ray agents, gastrointestinal tract for analysis. And other preparation, etiotrastum or idofindylate, and which had this structure, also used for studying gallbladder and biliary tract of the body. You can see that you take a lot of preparations which has aromatic structure and which has different using and different using. And our next lecture will also speak about aromatic compounds, and we take other preparation which have aromatic structure. Now our lecture is over. That's all. And after all of our lecture, I would like to say, take care of yourself and your family. See you soon, and thank you for your attention.